In this video, I want to have a look at the sum and product of roots of quadratic equations. So some problems might be concerned more with the sum and the product of the roots than the actual roots themselves. So let's have a look and figure out what we can do to figure out the relationship of the sum and products of roots without actually figuring out the roots first. So we know that a quadratic equation, if a quadratic equation has roots of alpha and beta, then we can write that quadratic equation as x minus alpha and then x minus beta equals 0. Now, if we were to expand this out, we'd end up with x squared minus alpha x minus beta x plus alpha beta. And then if we collect our like terms, so we're going to factor out that x. So we're going to have x squared minus alpha plus beta plus, x plus alpha beta. So here we have the sum of our roots, and in this bit we've got the product of our roots. But we want to know how that helps us. So usually when we're writing a quadratic equation in general form, it looks something like ax squared plus bx plus c equals 0. Now if we go through and rearrange this to make it a monic quadratic, we'd go through and divide everything by a. So we'd end up with x squared plus b over ax plus c over a equals 0. If we equate these two equations now, we can see that this coefficient of x in this one is that alpha plus beta, that minus alpha plus beta, and the coefficient of x here is b over a. If we look at the constant term on the end, the constant term in this first one is that alpha beta, and here our constant term is c over a. So we can equate the coefficients in both of those equations. So what we end up with, and this is straight from your formula sheet, is that the sum of the roots is equal to minus b over a, and the product of the roots is c over a. So let's have a look at what that looks like with an example. Okay, so our example says if alpha and beta are the roots of 2x squared minus 6x plus 1 equals 0, we want to find the sum of the roots, the product of the roots, and then these two other relations as well. So for part A, we want to find alpha plus beta. Now from our formula sheet, we know that that's minus b over a. So in this equation, b is the coefficient of x, so that's our minus 6. So we're going to have minus 6 over a, which is the coefficient of x squared, which would be our 2. So minus 6 is just a positive 6. 6 divided by 2 would give us 3. For part B, it asks us to find the product of the roots, alpha, beta. And we know, again, from our formula sheet that that's going to be c over a. So c is our constant term, which is 1. A is that same coefficient of x squared, is 2. So the sum of our roots is 3, and the product of our roots is a half. Now we've got these other ones which are slightly more complicated. We don't know what these are straight off, so we're going to have to manipulate a few things to get them. So the first one, or part C, asks us to find alpha squared plus beta squared. Now to get that, it's important to recognize that that is not the same thing as alpha plus beta squared. Because alpha plus beta squared, if we expanded that, we'd have alpha squared plus 2 alpha beta plus beta squared. So it's got this extra term in the middle. But we only want the alpha squared plus beta squared. So we want this bit and this bit. What we could do then is subtract 2 alpha beta from both sides. So we could have alpha plus beta squared minus 2 alpha beta, and that would give us alpha squared plus beta squared. So we're going to do that here. So we're going to have that equals alpha plus beta squared minus 2 alpha beta. And then we can use our solutions from parts A and B. So alpha plus beta was 3 and alpha beta was a half. So we're going to have 3 squared minus 2 times a half, which would give us 9 minus 1, which is 8. Right, if we rub this bit out, our last part, part D, asks us to find 1 over alpha plus 1 over beta. Oops. Now we don't know what they are separately, alpha and beta, because we haven't actually found what our roots are. But what we can do is we can make that into one fraction, make it have a common denominator. So if our common denominator is going to be alpha beta, we'd have to multiply top and bottom of this first fraction by beta. and top and bottom of the second fraction by alpha. So that would mean on the top we'd have alpha plus beta. But alpha plus beta over alpha beta, and again using our solutions from part A and B, we'd have 3 over a half, which is the same thing as 3 times 2, which would give us 6. All right, so that's a look at problems involving the sum and product of roots.